Hey, what is good, everybody? Welcome back to the channel. It's been 10 months since I made a video, so I really do not know how to record a YouTube video anymore. So bear with me on this one. But yeah, so in today's video, we are going to take a look at my sandbox game engine. It's called Ember. I've made a whole lot of progress in terms of understanding the underlying, systems that are required for an game engine to work. I basically did a few things that are engine related and a few things that are editor related. So in this video, we're just gonna go through some of the stuff that I've implemented and challenges that I might have faced, if any. So we'll just see how it goes. This video is really not scripted. It's just to basically just show you guys that it is possible to build a game engine, and it's very much possible to make it look as beautiful as it can be. So let me run this and show you. So voila. So what we have here is Ember. And you saw how quick that basically booted up, right? So it's written in C. Not C++, it's written in C, and I built it from scratch. Everything that you've seen here is built from scratch. There are no third-party libraries, there are no third-party anything basically apart from STB image, which I use to basically load images such as textures onto the engine. But apart from that, everything else is custom made, including the windowing system. And to prove that, you'll see that it's pretty janky right now. So you can see some the actual Mac OS underlying window texture color here, which is magenta. Is it magenta or mangantic? I really don't know. But anyway, it doesn't support resizing yet, this platform layer, although my previous platform layer, I do actually have a proper platform layer. It's just that this one isn't necessarily implementing screen resizing or anything like that. So again, it's just a sandboxed engine, something that I just whipped up to sort of like try and understand how to build a game engine. So to run this again, um, now everything is back to normal. So what do we have, and what have I built, and what have I accomplished here? So to show you guys, let me just hide the metal HUD here so you guys can see this properly. So what you guys are looking at is a rough implementation of a UI system, or an editor, I guess you can put it like. We have this UI system. It's a retained mode UI system. Currently, if we're speaking about how the rendering works for this, is that we basically have about 3 draw calls here. One is for the shapes themselves, like the panels that you're seeing here, the rounded buttons or circle buttons, or any shape that you see is actually instance rendered, and all of these shapes are basically rendered in one draw call. Okay, and then the second draw call comes for the text, right? So the text is not part of the draw call of actually drawing the shapes, right? So that's its own separate draw call. Okay, I put this under the UI because again, text is, well, it's still UI, right? So yeah, so that's 2 draw calls. And where's the third draw call coming from? These lines, right? Because the shapes themselves are SDF shapes, right? But in order for me to render these lines in the profiler, I cannot do that with normal SDF shapes. Well, at least I tried and I failed. So I had to implement a different technique, and that's just literally just drawing normal geometry. So these lines that you see is literally just normal geometries, like line strips. Um, and then you have this little area beneath it that basically is highlighted as well. So that's literally just actual geometry that I'm just generating per frame. But then I have a cap, so you can argue that I have a pool of reusable geometry. So it's just recycling it and doing whatever it needs to do with you know the vertices and its positions of each line every frame or every iteration. It's a little bit complicated to explain, but just now have a pool so that we don't infinitely generate lines and geometry here. Okay, so yeah, so that's that. And then that's the third draw call. However, the what you call this again, the color picker. The color picker is a widget outside the normal UI system, so that's its own draw call. So we can argue we have 4 draw calls, but again, I'm just going to consider this as an outlier because it's an experimental feature, something that I've actually had troubles with. Hence, it's its own separate thing, right? It's not part of the one draw core for the UI system, mainly because it contains gradient shaders here. So this is its own separate shader. So I had to create a separate draw core for this because I had custom shaders for the gradients. For the gradient colors and so on. So yeah, I could still make this one draw call, but I just decided to separate it. It doesn't really kill performance that much. However, if you do look at my metal HUD, we are eating up about 4 milliseconds to 3 milliseconds. That is because of my recording software along with the other applications that I have running in the background. So technically I'm actually just around about 1 milliseconds or even below 1 milliseconds. But the biggest performance hit is actually coming from this widget here, and along with the profiler, which is still not optimized enough for what it's doing here. Okay, so yeah, so that's how the UI layer works, and how I decided to approach it. It is retained mode. I haven't really experimented with immediate mode, but I do want to try it and see how that works. So we'll see. And then when it comes to text rendering, the text is basically rendered using what was this again? We used MSDF to render the text. So let me just bring up my Amber text here so that you guys can see. And I think I'm gonna move this to the right by 20. So let's just build the engine. The engine is done building. Then we just run it. And there we go. So we have the Amber engine text here, and you can see how crisp the edges are. And there's basically no jittering or anything like that. Everything is just smoothly crispy. Now, this is something that I had a bit of trouble getting right. Now, you could argue that once I am using MSDF, it was just a given that it would be this crispy, but I had issues with my shaders, and I realized that I had to change a few things to actually get it to work properly, and I'm glad that I actually managed to get that right. So yeah, and you can see that this text is actually below, or you can see through, I guess. I really don't know what that's all about, but I do think it's my z-index ordering. Oh no, it's actually the alpha. Yeah, it's actually the alpha. So let's just increase the alpha back and see if this actually fixes it. Let me rebuild first. So if we build, run this, yes, so now you can see it's actually full white. So it's not a z-index issue, it's just that the alpha was halved. So yeah, so this is how the engine works or looks like, and that's how the UI system works. Now, what about the 3D scene and the 3D world? So let me just rebuild this by removing this again and just reducing this to about 20. Maybe that will move it off screen. And then I build again, and then I run, and then boom. Okay, so what we have here is a 3D scene, a 3D viewport. I guess you can call it. It's not really a viewport. The UI layer is literally just slapped on top because it's not really a proper editor, and the UI system and the UI layout system is not complete. So it's not a actual viewport. It's just, I guess, what's left of the skin real estate here for you guys to see inside the game mode. So I'm just gonna close it real quick, and I just want to enable the skybox texture and also get rid of the default gray texture. And you notice that when I have a default gray texture, the load up time for the engine is pretty quick, right? But now because I'm actually loading bigger textures, which are about 8K textures, I guess, if I remember correctly. The skybox is actually 8K textures. So you can times 8K textures by 6. That's 6 8K textures. I'm not sure about the size. I think each texture is about 5 megabytes to 10 megabytes. I'm really not sure again. So it will take a while to actually run the engine, start up the engine. But yeah, so let me just run this. And oh, no, we didn't fix. We need to save the code and then make bold. And I need to use the all function to ensure that it builds everything, and then we can run this again, and you'll notice that it's going to take a few seconds to start up. That's mainly because it's loading all those 6 8K textures for the skybox. The engine itself is not multi-threaded, so it's a little bit inefficient when it comes to loading assets, such as textures and all the other type of assets, fonts and all of that stuff, right? So but yeah, but nonetheless we do have a proper skybox, and we can navigate throughout our 3D scene here, and we can continue to zoom out infinitely, I guess, if you will, and if you want to, you can do that if you like. But yeah, just wanted to show you guys that. And then we also have the ability to just reset the camera to a fixed position, and then we also have the ability to go up and down like this, and then also we have a gizmo system. So what you're now seeing on this cube is a gizmo system that I implemented. So if I toggle this to a transform gizmo, you'll notice that we have this little, cool little gizmo popping through. It's rendering on top of everything, including the UI layer, because these are actually not on different layers at all. It's just on one same draw layer, right? I haven't really separated them in terms of Z indexes and all of that stuff, right? So again, like I said, the UI is just slapped on top of the full window. So this is not an actual viewport. Okay, so yeah, and then we have interactivity here. We can actually move our cube, move it around the scene like so, and you can actually see that, and you can actually move it like this and like that and so on. And then you can basically have the scaling gizmo, and you can actually scale the gizmo, scale the cube down, or you can just scale it on one axis, or this one, or that one, or multiple at a time. So yeah, and then we also have a rotation gizmo. The rotation gizmo actually just hides the cube, mainly because I feel like this color is a little bit too overpowering. I will decrease its intensity just so that we can still see the item below it, and we can actually rotate the cube. It's a little bit hard to see, but the cube is indeed rotating, and if I just remove that, you'll notice that the cube has been rotated. It's no longer in its original rotation. Okay, so what just happened? Oh, I just reset. Okay, I hit my reset button. Anyway, so that's the engine that I have going on here. So yeah, that's what I've been working on in these 10 months. Basically just trying to figure out how to do all these things and how to get them to work properly and correctly. So yeah, that's basically it. What's coming up in the future? Well, I'm actually going to optimize all of this. Actually not even optimize. I'm actually just going to start from scratch and then just rebuild all the systems properly now that I can see that everything is indeed working. I have font texturing working, I have icon rendering working, I have widget rendering working, I have, all these cool stuff that will make up an engine editor working. I have Skybox, I have gizmos. We are well off to start basically adding stuff such as serialization, so we can start saving levels and maybe loading objects, 3D objects. We'll see how far I get, but it's gonna be a long-term project. It's not something that's gonna take like a few months or anything like that. It's gonna take a year or two, I guess. But again, this is just a hobby project. It's not really something that I am too hard on myself on. I'm gonna take as much time as I need, and if any of you guys want access to this engine, unfortunately you can't. It's gonna be proprietary. But if for whatever reason you do want access to the source code, just hit me up in the comment section, and maybe I'll start a Discord channel, and we can discuss the engine architecture there. I do want to note that it's actually running on Metal. We're not running on Vulkan. We are running on Metal, and it's running on my own Metal implementation that I wrote in C. So there is absolutely no Objective C code in this entire code base. It's just all C code. And I basically just rewrote the bindings for Metal. And thus, this makes this a complete C project. If you want access to um, the Metal C API, you can actually just look it up on GitHub. I actually do have it available. So it's called Metal C API. You should see the first one popping up, Ludacoda here. And if you open that up, you'll see that it has some examples. And some screenshots and a little bit of an API usage demo here. I haven't really updated this in 5 months. I still want to add Metal 4 support, so that is something that I'm gonna start actively doing. I haven't really done it as of yet. I've started with it, but it's not fully functional. But if you guys do want to help with that, do you want to contribute to this project, you guys can. You're more than welcome. You can create a pull request here and just contribute, man. And I'll just take a look at it and, review and approve if I need to. I do want to make a huge disclaimer as well that it's the unofficial implementation for C. Okay, it's my implementation. It could be inefficient. It could be, it could be improved. And if you do know how to improve it and you do have some techniques that are much better efficient than what I'm doing, you're more than welcome to create a pull request with your efficient implementation. Just give me a nice little summary on why it is efficient and why I should go with that implementation instead. I'm willing to learn from you guys. I'm not saying that I know everything. In fact, I do not know anything. So, yeah, let's just help each other and see how far we get. And yeah, so the reason why I have this page here is because the engine itself is still running on Metal 3, and Apple released Metal 4 with macOS Tahoe. So it's something that I'm still looking into porting the engine to before I actually start rewriting everything. I just want to port the sandbox to Metal for itself so that I can actually see how things are performance wise and all of that stuff, and then start a fresh project in which I actually just write everything with the intent of having it working properly and efficiently and still looking as beautiful as it can look. And this is proof that, hey, whatever people are telling you it's impossible, it's not, man. Like, it just takes time, and it really just takes dedication. And if you just persevere long enough, you can actually achieve anything that you want. I mean, I just built a game engine. It's not a full game engine, but it's the skeleton towards a full game engine. And you can see that we have PBR rendering here. It's not the best implementation of PBR because we still don't have actual reflections and all of that stuff actually supported just yet, nor do we have proper shadow cascadings and all of that stuff in here as well. Those are things that I'm gonna implement in the future, but for now I just really wanted to have the basis of what an engine needs to look like and feel like an engine at the end of the day. So my engine is called Ember. It's gonna be a proprietary engine. If I do get it to work and look pretty good, I might just license it out. Who knows, but we'll see how far I go. Either I license it out or I just put it out there as an open source project. But for now, it's closed source, and it will remain closed source until further notice. So yeah, if you guys watched until here, I dearly belovedly appreciate your time. And if you haven't subscribed already, do hit that subscribe button. And I'll try uploading more regularly in the future. But I just really just wanted to send out a video just to show you guys that hey, I haven't really abandoned my channel. It's still gonna grow. It's just that I haven't been really busy this year. So yeah, I'll see you guys soon. Cheers.